Data lakehouses have been on the rise when talking about modern data architecture, and in this video I'll be explaining to you what a data lakehouse is and how you can use it in managing your data. Welcome to Data Thinkbox, and in this video I'll be explaining to you what a data lakehouse is, where you can find one, what it does, how it can help you manage your data better, and what providers offer you data lakehouse environments. Before I jump into what a data lakehouse is, I'll walk you through the history of data management and the different architectures that have been used so far. In the late 1900s, data warehouses dominated how we manage data. SQL engines were the primary source of compute for managing data or for querying data. These data warehouses, they focus primarily on unstructured data, which means that these are data that have a highly enforced schema that follows the ACID principles, and also data that is highly governed and reliable. But down the line, as data grew, we realized that data warehouses were not sufficient for managing this data. You couldn't scale it upwards. It wasn't sufficient for handling other data types, especially data that is unstructured, like your JSON files, your packet files, and what have you. Also, we realized that these data warehouses cannot scale to large types of data, especially your streaming data. That created a problem, which led to the introduction of data lakes. A data lake is basically a repository for storing different types of data, both structured and unstructured data. The data can be scalable, it can contain large amounts of data. These data lakes seem to have solved the problem that was being faced by data warehouses. The new challenge that it posed was data lakes were built for scalable data, but the data wasn't reliable. You couldn't easily query it just like the data warehouses. The data in data lakes only follows schema on read process, which means that the schema of the data is based on when you read it and it's not highly enforced, unlike the data warehouses. And most of the times you end up seeing yourself managing two different architectures, one for reliability, the other one for scalability and flexibility. And looking at these two structures, it becomes more complex to handle your data. This led to the introduction of data lakehouses. A data lakehouse is a modern data architecture that lets you store different types of data, both structured and unstructured data, lets you transform this data, query this data, and present this data for analytical purposes or for AI. It basically takes the best sides of a data lake, which is storage of different types of data, and also the query capabilities of a data warehouse, which gives you the reliability of your data and the high governance on your data. This helps you build a modern data architecture that you can scale to different data, different volume, and still retain the reliability that you want from your data. Let's dive into the major components of a data lakehouse. These components are the major principles guiding how these data lakehouses work, how it helps you process data down to the end user. The first layer is the ingestion layer. This layer is responsible for letting you ingest data into the lakehouse using different methods, batch or streaming processing methods. This is a process that makes sure that your data can successfully arrive into the lakehouse. The next layer is the storage layer. When your data arrives into the lakehouse, it needs to be stored somewhere in a place where it can be scaled, where it can be managed properly. This is what the storage layer does. And it does this efficiently by knowing how to store structured data and unstructured data. The next layer is the table or metadata layer. This layer is responsible for storing metadata in your lakehouse. This can include your history data, which stores different activities going on in the lakehouse, or your logs, or your table metadata, how large your data is, the different definitions for your table. Then we've got the processing layer. This layer is responsible for managing different processing and data transformation that goes on in your layer, making sure that the data is cleaned and prepared for the downstream use cases. Then the next one is the governance layer. Your governance layer is responsible for making sure your data is secure, safe, and accessible, making sure that data privacy is maintained. Only people who should have access to the data have access to it, and protecting your data from unauthorized use. And the last layer is the consumption layer. This is where your data becomes ready and presentable to your business analytics tool or to your AI use cases, where the end users can make use of the data for different kinds of purposes. What are the benefits of a data lakehouse? Just like I mentioned previously, a data lakehouse is the combination of a data warehouse and a data lake. These two combinations gives you different good use cases. For instance, when you look at your data warehouse, it gives you the reliability on your data that you can trust because the data is well structured, the schema is enforced, so all the fields, all the columns, they appear where they should be. The data warehouse obeys ACID transactions, which lets you make sure that all the transactions are complete, all the records are reliable and properly governed. And also the warehouse gives you analytics capabilities, so you can query your data and transform it and use it the way you want. Moving on to the good sides of a data lake, you get the scalability of your data. You can store different sizes of data, different volumes. It can contain as much data as you want. It has the capability of storing different types of data. You've got your structured data, unstructured data, semi-structured data. This can be files, documents, text, tables, and what have you. And also with a data lake, you've got flexibility on the data workloads that you have. You can use notebooks, SQL queries, Python scripts to query and transform your data. This is due to the capability of a data lake, letting you handle different types of data and not just the strict and structured way of a warehouse. With a data lake, you also get the ability to use APIs, which is how most companies or most applications present their data to the end user. So with these APIs, you can query and extract data from whatever source that you've got the data in and ingest it into your data lakehouse where it's stored and being used for other downstream tasks. One major important benefit of a data lakehouse is it reduces duplication and data movement. When the two different architectures, the data warehouse and the data lake, were separate, there was lots of duplication of data where you've got data in your data lake, and because you need that data in your data warehouse, that data is created in the data lake and then duplicated in the data warehouse, and there's a bit of movement from one source to the other, which can lead to different complexities. It can lead to lack of data quality, which is what this data lake, a single unified source of truth for your data, helps you to solve. It eliminates that data duplication layer or movement layer and helps your data be clean and unified in one location. I know most of you will be asking, where can I get a data lake or where can I build a data lake? Most of the times, the data lakes are provided by the hyperscalers, which is the cloud providers, where you can scale and build your data platform. Some of these providers include Databricks, which is a purely data engineering product that is used for ingesting data, extracting it, transforming it, and loading it. It's really good because you make use of different data assets like your notebook, your pipelines to transform and process data. So another big player is Snowflake. Snowflake is pretty much similar to Databricks. It helps you to build your data assets end to end and provide it for your end users. Another one is Microsoft Fabric. Microsoft have been playing around in the data lakehouse field for quite a while now. So they've moved from Microsoft Synapse to Microsoft Fabric, and Fabric is the unified end-to-end data analytics platform that lets you build a data lake, ingest data into this data lake, transform your processes, and then store it in a warehouse. Then this data lake can be queried for any other purpose, like using Power BI for your data analytics or using Microsoft Foundry for your AI agent. So Microsoft gives you a holistic view of a data platform using Fabric because it contains everything that you need. Another data lake that you can look into is BigQuery. This is provided by Google. I haven't really played around with it, but I've seen people talk about it and it seems to be quite a very good tool. So hopefully with these tools, you can be able to create and build your own data lake houses. There are some other open source tools out there that you can use or you can build locally. The principles of a data lake, it remains the same whether you are building on cloud on your local device, so it's always there and you can use it. By now you should be able to tell which data architecture is suitable for you, whether you need a repository of unstructured files, which means you need a data lake, or you need a structured storage with highly enforced schema with high data reliability, which means you need a data warehouse. But if you need something that is scalable, that you can grow to other data types, and also want the reliability on your data and ability for your users to query this data, then you need a data lakehouse, as this gives you a unified platform for building your data. I believe you should be able to then tell what the benefits of a data lakehouse is and how you can start building out one, or what providers you can use to build out a lakehouse. I hope this video was helpful. Let me know what you think about it in the comment section. For more videos like this, please like, share and subscribe. Click on the link in the description to know more about the channel. I'll see you next time. Cheers.